Alright, we're going to go over FlyLab.js in more detail now. And what I'm going to do, we're going to at least start out with checking on how we can tell if something is dominant or recessive. Then we'll move to increasingly more difficult questions. So the first thing, let's take the example. Let's take a male fly here, and let's make its purple for mating. And then we're going to take now, if it's a dominant trait, we expect to see some flies in the results, right? You don't see that. See, these are female, so that means they're all wild type. These no PR over here. So we assume, hey, this must be a recessive trait. And to be a recessive trait, we should be, that means a lot of these flies are or actually all of them should be like big A, little a, right? They should all be heterozygotes. So if that's the case, then if we were to mate these males and females together, then we should be able to see some purple-eyed flies. And it should be in the ratio of, maybe 1 to 2 to 1. Let's check that and make sure I've done my math right. And let's cross them. And what do we get? Well, we get about 129, 132, about the same over here, male and females. So, and what do we get over here? Well, we're getting 350 and 350, 700 to say 250, yeah, about 3 to 1. So that would be because it's the dominant trait here is the normal eyes. That 1 to 2 to 1 ratio, the heterozygotes will be red-eyed, the homozygous dominants will be red-eyed, and so a ratio of 1 to 2 to 1 would leave you with about 3 times as many of these compared to these. And if we add that up, that's roughly 250, 260. So we would expect twice that, 3 times that over here. So 250, about 750. So 6, 7, yeah, just about right. So by doing this cross, we've proven here that the purple mutant here, this allele is recessive. And how we did that was we crossed what was our first cross? All right, it was a purple-eyed fly, which must have been homozygous recessive, and a female homozygous wild type. And of course their offspring were all dominant, right? They were all wild type. Well, that was males and females, so it's not sex-linked. So now we know that this is a recessive trait and that it is not sex-linked. And it works just exactly like we want. Now, notice the numbers are not perfect. It's not exactly 3 to 1 here. If you add these up and add these 2 up, you don't get 3 times. You get roughly 3 times, but it's not exact, right? So that's one test to kind of make sure that you understand how this is working. Now let's try something else. Let's now do this, let's reverse this and make it male and female and see if we get any difference. Okay, so I'm now going to make the female, let's see here. I don't want to do that. Let's see here, male, female, yeah, female, and we're going to go and change the eye color, and again to purple. And then the male will be wild. Alright, we're going to mate them. And you get the same thing. Alright, doesn't matter if it's male or female. You can select to mate this one and this one. Mate those flies. And you should get roughly the same numbers that you got before. Notice it's not going to be exactly the same. The software is designed not to give you the same amounts. but you get the same, essentially the same results. And of course, because these vary, it's designed to mimic real life. That's why we have to use chi-square. Chi-square will tell you if this is off too much, and if it is, then you can't make your conclusion that this is the way it worked. If I were to run these numbers into a chi-squared, it should come out within the correct values that don't let me go over it. Now, it doesn't mean that you can't. In the real world, sometimes the statistics don't work. You can, if you set your parameters so that it's 0.05% of the time you get it correct. 0.05% of the time you get it incorrect. That's kind of like the normal, not 0.05%, but 5% of the time, 0.05. What that number means is that, well, if we did this 100 times, the statistics would give you the incorrect answer 5 times out of 100. 95 times out of the 100, the statistics would give you the right answer. So realize statistics are fallible, and it is not, how do I want to say that? It is not 100% assured that the statistics will give you the correct answer. Never can be, unless you have all the information, and you can't do that. So you always, depending on like how big your sample size is, things like that will always control the probability that you get a wrong answer. If I have a jar of 100 marbles, and there are, say it's 50% of those marbles are green and 50% are blue, and I take 10 out, well, you would expect to get 5 of one color and 5 of the other if the statistics worked perfectly, but they don't. You might grab 10 marbles and all of them are green, and that just happens. The only way to know for sure what the ratio is to count all 100, and that's usually not feasible, and that's why we do statistics. All right, so this is the first little video, just going over some basics here, and especially on how to determine whether or not something is dominant or recessive. In this particular case, we showed that these flies were the purple eyes are a recessive trait.